Hey everyone, in this tutorial we'll build a drawing app using React and Three.js as always. The app will allow you to draw on a 2D canvas using a 3D painting brush model that follows your mouse movements. As an additional feature, we'll include a 3D rendering of Van Gogh's bedroom in Arles painting. It's a famous painting that you may know, which you can explore and interact with. We'll also add a 3D avatar of Van Gogh that can play animations and potentially be integrated with an AI system to discuss Van Gogh's history, artworks, and other related topics, since AI is interesting to everyone. By following this tutorial, you'll learn how to combine React and Three.js to create an interactive drawing experience, working with 3D models and animation, and potentially integrate AI for enhanced user engagement. Let's get started and see how we can bring together art, technology, and history in this project. Now let's get started with our first part, where we'll set up our project using Vite. To begin, make sure you have Node.js installed on your machine. If not, please install it. Search for it on Google, Node.js, download it and install it. Then open your terminal in your VS Code. I assume you are using VS Code, but you can use the editor of your choice. Then choose the directory where you want this project to be created on your local machine. So I want it in my desktop, so cd desktop. Then I will create a folder for this project, but I will create it using the command from Vite. For that, npm create Vite at latest. Press enter. Then here you can choose the name of this project. For example, drawing 3D app or 3D drawing app. Tut for tutorial or tutorial. Here choose React. So Vanilla, Vue, React, etc. Choose React. Then choose JavaScript. And this is done. Now simply run npm install, as you can read it here, and npm run dev to run the project live. I will open it first. So desktop, 3D drawing app tutorial. You can see I have the project created here. You see all the files. I will open the terminal again and npm I or npm install to install all the dependencies, and you will see another folder here named node modules, which is heavy as a black hole that contains all the tools needed for a Vite project with React. So we have there all the dependencies needed. And we will install also some other libraries like React 3 Fiber, and Dry. And I will do it in a moment. Okay. Now we have these node modules, as you can see here. Now we need these libraries: 3 for Three.js, React 3 Fiber, which is our way to render the 3D in the React environment, and also Dry, which is another library with useful tools and hooks that we will use, and you can see. So just make sure that you are inside this directory when you npm I, okay? So you should be inside this directory. I just opened this with Visual Studio. I opened directly the folder. But in case you were inside the terminal, just make sure to cd and this new project that you created, okay? So just navigate. You can try to see where you are with pwd. I am inside this folder here, and I can install the dependencies and the other libraries that I need, which are npm install 3 at react-3/fiber and then at react-3/dry. So 3 React 3 Fiber and dry. Copy this and run it. It will install the 3 library, the React 3 Fiber and dry library. And you will have it here together with the other libraries and tools in the node modules. And you can see it in the package.json what dependencies you have installed for this. So for example, we have React 3 Dry, React 3 Fiber, React DOM, which is part of the DOM to use React, but is a separate library, and 3. Okay. And these are dev dependencies, never mind, just slint, void configurations, etc. And we have the commands, so the script to run the project. So dev is npm run dev, just to run the project live. If we want to build it, and this is when we want to deploy it on a hosting platform, we will use this npm run build. We will create this folder. Then this folder will be pasted in the hosting platform. Okay, but for now, we don't care about that. And this is for the lint. You also don't really care about this at this moment. Lint is to add some rules to your project. And you will see yourself these warnings from lint, from slint. What else? We have the libraries installed. Now we can create the basic structure of our application. But first, let's clean a bit the code here. Default styles in the index CSS, also in the app CSS. These are some default styles. And we have this main component in app.jsx. This is the main component rendered live. You can check with npm run dev and then click this localhost and check the project live. So take a look. This is the default view of the application. Just a standard design here, Vite plus React, just to show something that is built with Vite. Okay, let's remove this. We don't need this. We will add the canvas, our 3D scene, our 3D objects, and everything that we need. Okay, so let's start by cleaning a bit the code. Here, let's remove everything. In index CSS, let's remove everything. In app CSS, let's remove everything. We will get some errors because it will show that you cannot find the file CSS, etc. For example, okay, here in the main.jsx, you are importing this index CSS. You have no errors because we didn't delete it, we just deleted the code, okay? Let's leave it, these files. We will not delete it, we will use it later, but just delete the code inside. So we will not get errors. We can also delete this Vite icon and in the assets React icon, or you can just leave it, it doesn't matter actually. And let's start by creating a simple component, a simple React component. I have some snippets to create quickly a React component. So I simply write air f air a f c, and it will create this export const up. Okay, it's a simple React component. But since this app.jsx is the main component, I will use export default instead of export const. In the other tutorial, where I'm building the 3D classroom, I'm talking about this in detail. Okay, so I explain every concept in React and in Three.js, so you can follow that to understand better the fundamentals of React and Three.js, because we will not stop and explain everything in this tutorial. Okay, so let's make this an export default component. Okay, so we have this simple React component returning a div with the app text inside. Instead of this div, I will return another component, which will be the main component having our drawing app, or let's call it sketch app. Okay. Okay. This component doesn't exist. You can see SketchUp is not defined, of course. We don't have a SketchUp component. We will create it. So in the src folder, create inside another folder and name it components. This will contain inside all the components. And here, SketchUp.jsx. Again, with the snippets, let's create another simple component. Air AFC. This is export const. I don't need this import React from React. So we have this SketchUp. Let's import it here. So we get rid of that error. Import, it will be suggested. SketchUp. And here it is. So we don't have the error anymore. So as you understood, we have this app component, which is the main component of React. And we will render inside here other components, which will be children of this main parent, which is a way that React uses to render the components inside. Okay? So here we will have like, I don't know, navbar, footer, etc. And they will be rendered based in the order. Okay? For now, this is empty. We don't have anything inside. We are just rendering this SketchUp text. And if you go and take a look at the browser, you will see this SketchUp rendered in the scene. I mentioned scene here, but we are not really using the scene yet. We will use it by importing canvas, but let's take a look if we see this SketchUp. And yes, we see it, this SketchUp text. So since we have no issues, let's start importing the canvas from React 3 Fiber. And again, if you want to know in detail what canvas is in React 3 Fiber, its relation with Three.js and everything in depth, I talk about these concepts in the other tutorials on 3D Classroom, but also in the other tutorial where I build the Sky Island, and I also talk about this in the Art Gallery tutorial, but that is based on the Three.js perspective. Okay, if you want to know from the React 3 Fiber perspective, take a look at the other tutorials, the Sky Island tutorial and also the last one, which is the 3D classroom with AI tutorial. And to import the canvas, at the top, easy peasy, import canvas. Here it is suggested, click it, from React 3 Fiber. Okay, that's it. It will be complaining here that this value is never used. So let's use it. Instead of this div, let's return the canvas component. So canvas, close it, and we have this component. Okay, inside we will render all our 3D stuff. Okay, if you want to dive deep into these concepts like canvas, its relation to Three.js and everything, please take a look at my other tutorials, like the one on the 3D classroom and the other one on the 3D island, where I go in detail into this. Okay, but briefly, here we are importing the canvas component from React 3 Fiber, which serves as the foundation for our 3D scene. The canvas component, let's say, is like the blank canvas in the painter's studio, since we will use this Van Gogh drawing up. So the analogy is with the painter's studio. The painter has a canvas, and let's say that canvas is a blank canvas, but it will provide the space where we can create and arrange our 3D objects, and also the lights and the cameras. Just like how the painter will use the brushes and the colors to bring their ideas to life on a canvas, we will use React 3 Fibers components to build our interactive 3D drawing app using this digital canvas. Okay, this is our digital canvas, and the painter will have their canvas. That's it. Briefly, what canvas is. But again, if you want to go deeper into this, please check the other tutorials. Now let's create the component for the 2D canvas that we will use to draw. Do not confuse it with the canvas from React 3 Fiber. This will be the canvas in the browser, the 2D canvas, to draw in the browser, okay? Let's create a new component here. Let's make it a folder because I will use the styles. Name it drawing canvas. Oh, this is the folder, sorry. Inside two files. Drawing canvas JSX and drawing canvas CSS. First, let's create the basic structure of this component and define the necessary state variables using the useState hook. Again, to go deep into this useState and useEffect hooks, please check the other tutorials, okay? First, let's import this useRef, useEffect, and useState from React. Then create a simple component with my snippets. Delete this. Named drawing canvas. Here inside, I want to render drawing canvas and the color picker. Make this a fragment at this moment. Now let's create the useState variables that we will need. First of all, the color. We need a color to draw, so a state variable for that. I will use the snippets, color and set color. Initially, let's make it black. So 1, 2, 3, 4, 5, 6. It is the black color. Okay. What else? I also need the stroke width. I will make this stroke thinner or thicker. So let's use a state variable for that. And the initial value, let's make it 5. This will be the value of the stroke. We will have a range, so let's make it 5 for now. Then I need a boolean. This boolean will be if is drawing or not. So to check, is it drawing or it is not drawing? Okay, because we will have this logic if it is drawing or not. So is drawing boolean. Initially it will be false. It is not drawing. Now I need to create two refs. One for the canvas element, and I will name it canvas ref, and another one for the canvas context, and I will name it context ref, and I will use for this the useRef hook. So declare a variable const canvas ref equal useRef. Same thing, but name it context ref. And now we will set up this canvas and context. Let's set up them. I will use the useEffect hook here because I want to get the 2D rendering context using this useEffect hook. First, const canvas. The canvas will be this reference current. Canvas ref dot current. I will explain the things here. Do not worry. Then const context. Context ref dot current. So we have these two variables for the canvas and the context. They will get the current from this ref. So using this canvas ref dot current, we access the canvas element. I will use this reference here in the component that I will create the canvas later. Okay, so inside this return, where I will add the canvas, it will be a simple component like canvas. Okay, and I will add here the reference. Okay, so the canvas ref. So like ref canvas ref. Okay. So now I want to set the dimensions of this canvas to twice the window's width and height, and this to support high resolution displays. Okay, so I will set the dimensions to twice the windows in the browser, twice that width and height to support high resolution displays. Okay, so this canvas variable that I just created, dot width equal access the window object dot inner width, and this is to access the width of the window, and times 2. Okay, the same for the height. Copy paste, height, and here inner height. Okay, okay, this is uppercase. And the same thing for the styles. Canvas dot style dot width equal this window dot inner width pixel. The same thing for the height. Inner height. Now let's handle the context. We will get the 2D rendering context using canvas.getContext, and we will pass the string 2D. Okay? So let me show you. Always inside this use effect, const context, using the canvas, this one that we created, that get context. This is the method to get the context. And inside, pass 2D. And let's configure now some properties, such as the scale, the line cap, the stroke style, and the line width. Okay, these are some properties for this context. Okay, context dot scale to the parameters. Context dot line cap equal string round. Context dot stroke style equal color. So this is the color that we have here at the top that we created as a state variable that initially is a black color. So what else? The line width, context that line width, it will be this one, the stroke width. Oh, I have an error here. Good that I saw it now. So it's not set stroke width and set stroke width. So stroke width and set stroke width. This uppercase. And let's set the context ref dot current equal context. I will pass here as a dependencies array color and stroke width, because every time I change the color and every time I change the size of this stroke, it will be re-rendered, and re-rendering we update our canvas. Okay, so everything you put here, the variables that you put here as a dependency array, makes possible to re-render the component. And I explained everything in the other tutorial in the 3D classroom, which is the React 3 Fiber project, and there I go in detail, like explaining every line of code, but I will not do it in this tutorial because it will be boring for you, repeating always the same things. I think you follow to learn new things. So, in summary, we are using this use effect hook to perform side effects when the component mounts or when the color or stroke width will change. We access the canvas element using canvas.current and sets these dimensions to twice the window's width and height to support high resolution displays. Then we get the 2D rendering context using this canvas.getContext and pass in this 2D. Okay. Then we configure these properties such as scale, line cap, stroke style, and line width, which are, the properties for the lines that we are drawing. And then finally, we store the context in the context ref for the later use here. What to do now? Now we will implement the drawing logic. So let's implement the functions to start, to draw, and also to stop the drawing process, because we need this starting function to start the drawing. Then we need a function to handle meanwhile we are drawing, and also we need a function to stop the drawing process. Okay, so we have defined three functions here: starting, drawing, and stopping the drawing. Let's do that. And let's create three functions for that. First, const start drawing, make it an arrow function. Then we set a function for the drawing. So const call it draw. Oops. Okay, I forget sometimes the syntax. Come on. It's here. And we have the function to stop the drawing. Const stop drawing. You know what? I really hate these lint warnings. I know it's useful, but come on, I really hate these warnings all the time. So please, I know that its value is never used, but just leave me alone. Hide it for the entire files. Okay, now they are gone, but I don't want this here and to push it, on GitHub, or just to make it, ugly. I will grab this text here, no unused vars, go to this slint file, and here in the section rules, at the top or behind this rule, string, put this no unused vars, comma, string, and off. Put a comma here. And now if we go back and delete this, we don't have the warning, okay? So bear with me, I really hate those warnings. Call me a bad developer, but I don't like slint warnings. So we have these three functions: start drawing, draw, and stop drawing. Let's implement the logic for that. Starting with a start drawing. This start drawing function is called when the user starts drawing, as the name suggests. It retrieves the offset x and y, which are the coordinates from the native event. So here I will pass this object native event, and I will destructure the coordinates for x and y from this native event object. Okay, so to destructor, const offset x and offset y equal native event. So we destructure this offset x and offset y from this native event. So after retrieving these coordinates from the native event, I want to begin this path of, our line that we will draw in the browser. So we need to begin this path. And to begin this path, I simply use the reference that I created, the context ref dot current, and then access this method, begin path. Then what I will do is I will move this drawing cursor to the starting position using a method named move_to, and I will pass inside these coordinates. So follow me. Context ref dot current. I said we will use this method move_to and pass inside these two variables. So offset x and offset y. And then I want to set this state variable is drawing to true, because it will be true. So I am drawing. And to set this variable, we use this setter function. So set is drawing. Okay, here where we are. Here, call that setter. So set is drawing, parentheses to call it, and pass true, since initially this is false. So this is the initial value, false. Here we are setting it to true. This is for the start drawing, so we start the drawing here. Okay. To recap, this is called when the user starts drawing. It will retrieve its coordinates, offset x and offset y, the two coordinates, x and y, and it will retrieve it from this native event object that I pass here. And it will begin this path using this begin path method. So, okay, we get this context ref dot current, and we'll use this begin path method. Then we move this drawing cursor to the starting position with this move_to, and then we set the is drawing boolean to true. So we are start drawing. So we know that we are start drawing. We can pass to the other function here, to the draw and then to the stop drawing. This draw function will be called whenever the mouse moves while drawing. Okay, so while we are drawing, we move the mouse. It means that we are drawing. So it will check this is drawing boolean if it's true. If it's true, it will retrieve the current coordinates. So let's add this since we have the logic here, okay? So this function we will call whenever the mouse moves and while drawing. Let's check, are we drawing, to retrieve the coordinates. So add an if statement, are we drawing? If we are not drawing, and for that, to make it the contrary, we add this exclamative. If exclamative is drawing, it means if false, so this is false, then first simply return. Then, if drawing, we will retrieve the coordinates. So const. The same thing that we did here. Let's just copy and paste. If I had GitHub Copilot, I will finish here very quick, but I don't have it. I used it for some months, but then I did not pay it anymore. But maybe it's a good thing not to get used with GitHub Copilot, or maybe, I don't know. What you think? Okay, so I get this, I retrieve these coordinates x and y from the native event object. Now, what I want to do is to add a new line segment to the path, and I will use a method for this, as I did previously with move2 and the other methods. I will use another method. So context ref dot current. You always use this current to get, context ref dot current. Let's use this method line2, not move2 but line2. Open parentheses to call this method and pass inside this offset x and offset y. Native event is not defined. Yes, is not defined. Here, pass it as an object. Now I want to stroke the path. To stroke the path, context ref dot current always dot, can you guess? Okay, you can guess, stroke. And that's it for this draw function. Again, to recap, this function will be called whenever the mouse moves while drawing. It will check if its drawing is true. It will retrieve the current coordinates. It will add a new line segment to the path using this line2 method, and then the stroke to the path using the stroke method. Again, let's go now and write the logic for the stop drawing. And this stop drawing is the function that will be called when the user stops drawing. Easy. It will close the current path, and we will use a method which is, again, is very intuitive. So here we just want to close the path. Context ref, always that current. Can you guess? Of course. Just close path. And what happens here? As we set the drawing to true when we start drawing, we will want to set the drawing to false when we stop the drawing. Don't forget to change it here, false. That's it. Now that we have this three function for the three stages, let's go here in the canvas. What we want to do? First, we wanted to pass this the reference, which is canvas ref, and we already did that. Now we want to pass some event listeners. You know what event listeners are? And these event listeners for listening to the drawing will be on mouse down. Let's write them down. On mouse down, you see it is suggested. And what we pass in the mouse down? We pass the start drawing. Here we go. So we have the first process. We start drawing, it is the on mouse down. Because on mouse down, it will check if, the mouse is moving and it start drawing. Because, with on mouse down, it will check later when we are like dragging the mouse and starting the drawing, starting the path of the line. You can guess here again. So we have the drawing. So we said that the drawing is while we move, and for that we have another event listener, which is on mouse move. Mouse move. And you know what we pass here? No need to tell you. We pass the draw. And the last thing for stop drawing. For the stop drawing, I will use two event listeners here actually. One is on mouse up. And on mouse leave. So if you want to go deeper and check this, it's easy. Go and check the documentation or MDN. Check all these event listeners, what they do, like on mouse down, on mouse up, like all these listeners that checks the mouse, its behavior, if it is moving, if it is stopping, if it is starting to click and move, you can check everything, uh, just for the curiosity and to learn more in deep. But here we just explain in the surface, because we don't really need to go deeper on each of these event listeners because they are also self-explanatory. Okay, so we have the logic here. We pass these event listeners. So whenever the on mouse down, we start draw. Whenever on mouse move, it means that we are moving the mouse and we are drawing. And then we on mouse up and on mouse leave, it will stop the drawing. Okay, easy as that. Set also a class name because I will add styles later and target this. So class name and add the name for this canvas. Drawing cards, simple as that. Remove this content because we are saying here that to remind myself that we will add here the drawing canvas. We already added and the color picker. So let's add the color picker. It will be an input. Okay. It is complaining because in React we need a wrapper if we have more than one. You see here. JSX expressions must have one parent element. So we need one parent element. But I thought I already had this one parent element, the fragment. So, but I had that curly brackets. Okay, so we have this one parent element, an empty fragment. Whenever you want to wrap several elements in JSX, use just a simple empty fragment. It's just like a simple div, but if the div will show in the browser as an element, this one will not show. Okay, its function is just, let's say, to wrap in this case, because it will not show as a div if you inspect it. So we have this div color picker. I said we need an input for that. And the type of the input will not be a text, but it will be color. And also the value of this input will be color, is the variable that we have at the top. This one, which initially is black. So what else? We need an event listener here on change that checks every time it changes. You will add a value to it. Okay, so every time it changes, you will add a value. You can create a function up above and then pass that function here for this to handle this on change. or you can simply pass create it here. So on change this one, we pass an arrow function here. It will get this event object. You already know this. I'm sure you've done it hundreds of times. So we call the set color, the setter function here in the state variable, set color. And to change it, how we change this? Again, you know it. I said it, that I'm sure you already done projects like this to handle the inputs. It's the same thing. Nothing changes. So we get this E, which is the event value, E, that target, that value. So we get this value that changes whenever we type something. If it is a text, you know, when you create an input with a value of a text, whenever you type something, you get this value that changes. But in this case, it's not the text, like it will not get the text, but it will get the color whenever we change the color. So in this case, we have a color picker. We change the color picker inside, and we get that value here. Okay. Apart from the color, we also need for the stroke width. Okay, because remember at the top we have this state variable stroke width. As we pick the color, we can also choose the stroke, how thin or how thick you want it to be. Let's create another. Here is the color picker. Below an input, it will be not type text, not type color, it will be type range, because we will have like a range of to drag, to slide, and choose how thin or how thick. So type range, and we will set this range to a minimum and the maximum. Okay, so for that, min 1 and max, let's say 20. For the value, here is the value color for the color picker, and here it will be, the value would be the stroke width, this state variable, that it will change in time based how we are choosing to change it. So value stroke stroke width. Here we go. And what else? The same thing. We need an event listener that whenever it changes, get that target value from the event object. So event.target.value. It's the same thing. Get this here and pass it here. It will not be set color in this case, but it will be this set stroke width. Okay, and we are done with this. Actually, this main div here, the color picker, I need it to wrap both of these inputs, because I will style it later. You will find the styles here in the drawing canvas CSS. Just copy them and paste it. So if you want to follow the tutorial step by step and want to get the code that I am currently in the video, do not go to the final code in the GitHub repository, but in all the tutorials, if you want to follow step by step, I make the tutorials so that I commit every time we are doing like a process, okay? So a main part, I commit the changes. Then we do something else. We finish a task or a part of the tutorial. I push another commit. So go to this commits section in the GitHub repository, click commits, you will see the list of the commits. And there, in the list of the commits, you can simply navigate to that specific point in time. Okay, so that you can follow step by step. So you can check what is the current code in this part of the tutorial. Okay, so you will not inspect the final code, let's say, if you want to follow along. So we finished here. I will add the styles and you can copy them. To summary, in this step, we are rendering the canvas element and attaching the necessary event listeners. For example, this on mouse down, on mouse move, on mouse up, etc. And this will serve for the drawing. Then we are rendering these color picker elements, including an input of type color for selecting the drawing color and an input of type range for adjusting the stroke width. Okay, that's it. We can move on, but first let's try if we can draw or not. What do you think? We will have an error or we can draw? Let's try. No, we cannot because I completely forgot. Bear with me, guys. I will explain. Yes, we finished this component here, but it is not called anywhere. Because here, okay, so it is called here, but it's inside this canvas. And if you call this 2D elements, we have 2D elements here. We have HTML elements, you see, input, etc., etc. Inside a 3D component, which is this canvas, you will get errors. And it is very common to get these errors. So if you see this error, for example, error React 3 fiber input is not part of the 3 namespace. Did you forget to extend? You will get very often this kind of errors. So an element is not part of the 3 namespace. Did you forget to extend? This happens when you mix HTML elements with React 3 fiber. Okay, you will get this. Usually, to bypass these errors every time, you can wrap with an HTML from dry. Okay, HTML from dry. If you wrap this HTML elements with this HTML component, okay, you will get rid of this error. But in this case, we're not doing that because we will use a simple way to just remove the canvas at this exact moment to test. Okay, remove the canvas here. Is this correctly imported? Okay, because I have a folder here. Now let's try and draw. First of all, we don't have any errors. Let's try. Okay, it works. We can draw. You see? Close this. Now let me express myself, my artistic side. When I was a kid, I always drawn a house. Always. It was the same thing every time. I made the windows here. I added like this Okay, the door. I always edit like a lamp here. Okay. And the sun. Always the sun here. And the trees. Okay, I know it sucks, but and it just reminds me of my childhood. You know, guys, that I was a painter when I was a little kid. I followed courses on painting. I used to play piano too because I went in an art school. Okay, yeah, I like it. Do not laugh at me. It's cute. So we have this canvas. We can draw. Now, let's move on. So the next step would be to import the 3D model of the painting brush. So we can draw with a 3D model. So it makes our app a 3D app. Okay. Here in my public folder, I already imported these models. You can take a look at the description and you can find the links, or you can download these models in my GitHub repository. Okay, put them here in the public folder so we can use them. So as I said, we will import this GLB file of this 3D paint brush. A GLB is a GL transmission format binary. Okay, GL transmission format binary. It is a binary file format for 3D models that includes geometry, materials, animations, and scene hierarchy. Okay, we also have GLTF, but basically it's the same thing. So for the web, the most used and optimized format is GLTF and GLB. GLB is harder to read. If you go and click on this, even VS Code cannot open it. You need an extension, but it's like unreadable. GLTF is more readable, like in a JSON format. You can read the properties inside. But GLB is harder. But GLB has better performance, let's say, because it's compact. Okay, so we will use GLB, but here's the interesting thing. Since GLB is harder to use in a React environment, we will make possible that to work with this GLB file in the React application, we will convert it into a JSX component as any other React component. So from imperative world of Three.js into a declarative JSX component in React. And to do this, as I did in all my previous tutorials that I made on React 3 Fiber, we used a tool called GLTF JSX. Okay? One word together. GLTF JSX. Or this time we will use an alternative, which is a website online. It's easier in both ways. Okay, let's use this time this website. And this website will help us generate a React component that wraps the 3D model and provides a convenient way to import and render it in our application. Yeah, let's take a look together. So this is the website, gltf.pmnd.html. Arles. Okay, so drag and drop your GLTF or GLB file here, and as you can see here at the right, in just 1 second we can render this 3D model and have this code. You see, easy peasy. This code here is a JSX component converted from this GLB, and this GLB usually it's like thousands of lines of code, not hundreds but thousands. Okay, and it's very hard to read. You cannot really read it, but you can read this. As you can see, we import React, we import this useRef to add a reference to the model, and just another simple React component. Export function model, it accepts these props. Then we destructure these nodes and material from this model, which is just a path that we use this use GLTF, which is a React hook, but it's from dry the library. So we just destructure the nodes and materials. We can also destructure here animations and everything. Okay, so we can use them. And then we return this group. As you can see, it's a group that inside has maybe some weird code to some of you, or some of you may be familiar with it. But to explain to those that are beginners that never seen such a code, this component renders a group element that contains the 3D brush model. That's it. The easy idea is this. So this group element that contains the 3D brush model that you can see at your right. We just apply here some transformations to the model, such as position, rotation, and scale. As you can see here, position, rotation, and scale. For the rotation, we use this formula math.pi, which is nothing else than the pi. Okay, and here is in degrees. So 0, 0 for y and z, and math.pi is simply 180 degrees. In this case is negative. Okay. What else? We have this mesh elements here. And the mesh elements are nothing else but representing the different parts of the brush model. And we assign the corresponding geometry and materials to them, because a mesh is made of a geometry and a material. Basically, the mesh is the 3D object. Okay? The mesh needs a geometry and a material. This geometry and the material creates this mesh, which are different parts of the brush model. A mesh can be whole 3D object or different parts of it, depending how the 3D designer made it. Okay? I talk about this again, but I talk about this in detail, and I go really in detail, line by line, explaining everything in the other tutorial on the 3D classroom. Also in the other tutorial on the Sky Island. Okay, so again, for anything deeper, they are like 5 hours tutorials, so okay, you can go and check them. But we will make this shorter, because I received some dislikes on that tutorial on the 3D Classroom AI. I don't know. I say I don't know as it is perfect, and then I wonder why. It's not that I wonder why. You dislike, it's okay. I wish you peace in your coding journey, but I suppose that if some people dislike the video, maybe there is something wrong. I thought that I put effort to it, and I think it was done like technically good, but maybe it's boring, maybe it's, I don't know, maybe I drag the concept too long, maybe I explained too much the things, like details. Maybe people are bored because of this. I don't know, but I am not receiving feedback, so I can improve. So if you have anything that you don't like, the way I explain, the way I speak, I don't know, the way I code, maybe I made mistakes, let's say, in engineering, like I may write better code, let's say, or better design or architecture or structure, or I don't know. So let me know. Mm, Like I'm okay with any feedback, really. So anyway, to continue, we said that this component renders a group element that contains this 3D brush model here. Let's get this, let's open this to check a bit. So we have types, shadows, if you want shadows or not, you see the code changes. Actually, we don't need shadows because we will use this brush in the browser, so it's supposed just to draw, so it's not that it needs shadows, okay? It's not like a chair standing there and we need the shadows there to make it look better. So we don't need shadows. So uncheck this one. Okay, so the code here is even shorter. It's like 10 lines of code from 1000. Okay, because it really is too long if you check the gltf or glb file, lines of code. You has this precision, like how, because you make it lighter, because you reduce the size here with this conversion. With gltf JSX, it has an option that dash dash transform, and with that optional command, you reduce the size of the bundle up to 90%. For example, if you have a file, a GLB that is 10 megabyte, you can make it like just 1 megabyte. And it's really, really a good thing because it improves performance. Okay. I'm not sure about this website though. If it reduces the bundle size, I didn't test it in detail, but yeah. Anyway, we get this 10 lines of code, which is a great thing, and we have a simple React component, and we can understand it, and we can work with it. So we are happy. Copy this, or you can copy here to clipboard or download the zip, or download the image of the render. So copy, go to your VS Code, and here in the components folder, create a new one. Name it painting brush or whatever you prefer, and paste it. Oh, sorry, I need to paste also the credits here. So it's no bueno, no bueno. Without credits, no bueno. Sorry to this guy. His name is 3D Domino. Thank you very much, 3D Domino. Everybody go check his website. We have this model thanks to him. So 3D Domino, check him. He doesn't know that I exist and this video exists, but yeah, we should thank this guy. Okay, paste it here again. Let's leave these credits here. Okay, again, this ESLint warnings that I hate them. Maybe I'm not a good developer for this reason, but I hate them. Grab this here. Go to ESLint file. Where is it? Okay. Put the strings. right here off, get off as length. Okay, get off. We don't have the errors anymore. Okay, I will delete this just for readability at this moment, but I will add it when I will commit in the GitHub. So in the GitHub, we will have the credits. Okay. So we have this React component. Let's do something. Grab this path here and instead import it like this. Import strings, just slash, because everything inside public invite, you can just access it like this. So slash painting brush. Okay, you can simply access it like this in the public folder. Oh, I'm sorry. So import path model, we need a variable for this. That was the whole idea, to create a variable path model from this. And here, add this variable. You need to do this also when you deploy, because you will not have errors. Path model. Okay. Also, there is a nasty error every time you work with GLB files, invite, and I get messages by mail on this error. So if you get a strange error like saying something about GLB or any kind of strange error after you add your GLB model, go here, invite config.js. You see this file here, this anonymous guy that we never checked, invite.config.js. There are just some configuration on invite. And here you may not have this, or actually you don't have it. So you have this. Okay, you have this. You should add this line of code. Assets include blah 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 GLB. Okay, just copy it. Copy here by watching, or just go in the repository. It should be there. Okay, make sure to have this in the invite config.js so you don't have errors. And then you don't write me by mail. You can write me by mail, it's not a problem, but you can solve it. Easy peasy. Okay, so we have this component. Now let's integrate it into our SketchUp component. And let's set up the scene and everything so we can see this in the browser. So go to SketchUp here. Let's import this. What's the name? Oh, I made a typo here. Painting. Okay, let's fix. Painting. Okay, and here, instead of model, which is not very intuitive, what kind of model is, I prefer to change it to painting brush. Okay. Import. Painting brush. Suggestion. Here. I will remove this drawing canvas from this component SketchUp, and instead I will import it directly to the app main component, and I will explain why. But for now, let's import this painting brush. Okay, and here we can add like other 3D stuff that will be inside the SketchUp. Okay, like our Van Gogh avatar. it will be imported here, okay, later. So remove this import of drawing canvas, because we don't have the canvas from React 3 Fiber here. We need a canvas. And to have a great performance, we need only one canvas, not importing the canvas multiple times. So since app component is our main component, I would prefer that the canvas to be imported here, okay, and then use the other components and render them. So first of all, import the canvas here. First thing first. And here in the return, okay, and inside the canvas, let's put this SketchUp. Okay, you see SketchUp now is inside this. And this SketchUp will have the painting brush and the Van Gogh avatar. But for this drawing canvas, which is the 2D canvas that we are drawing, it has the logic, but it has HTML files. Okay, you see we have these inputs, etc. So it will conflict with our React 3 Fiber world. HTML and React 3 Fiber in the same place will conflict, and you would get errors like is it supposed to be here, blah blah blah. Okay, usually you get around with it by importing the component HTML from dry or dray, I don't know the pronunciation, but not every time it works. And I'm not stopping here and explain why it will not work in this case, because it will be too long. But I'm simply suggesting that the HTML wrapper to wrap React 3 Fiber and HTML elements in this case will not work because of the drawing. That HTML from dry will not let us get the context and the canvas reference, so we will end up in problems. Okay, the solution is to import that drawing canvas here, to have only one canvas but not imported inside the canvas. Now let's try it inside the canvas. So import drawing canvas, where is it? Suggested, please. Drawing. Okay, it's not suggesting. Why? Why? Drawing canvas. Come on, suggested. Okay. Is it export const? Okay, export const. When it's export const, you add this curly brackets. If it is default, like app.js is, you don't add these curly brackets. From, let's do it manually. I don't know why it is not suggesting, but anyway. Components, drawing canvas, drawing canvas. Let's add it here. Let's check in the browser just to see what errors do we have. Okay, the famous error that I mentioned. So on code error, React 3 Fiber, input is not part of the 3 namespace. Did you forget to extend? No, I did not forget to extend, but we are experimenting here, okay? We will get rid of your nasty error. And no need to read anything above. This is the main error that you should read. So blah 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 element is not part of the three namespace. Did you forget to blah blah blah? Okay. As I said, usually you can go around this error by wrapping HTML and 3D stuff inside this HTML component from dry, just to make a test. So let's test it here. Import this HTML I said. It will be suggested React 3 dry. So import HTML from React 3 dry. And here, as you can see, this is the logic. So variables, logic, use effects. It's not the HTML elements. But here, where we return stuff, this is HTML. So canvas, div, input, etc., etc. This is all HTML. So to get around that error, wrap all this in a HTML component from dry, this one. Okay, as we wrap it, the error should be gone. Let's check. But we will end up in other errors, as I said, but whatever. Just to understand that this error can be fixed with this. Even though in this specific project, it will not work for us. And these are those cases that you don't have much information online, to be honest, on this. And you don't really know how to search for it on Google or on Stack Overflow, because it's very specific. And if you ask ChatGPT or any other intelligent digital form that will steal our jobs, they will not help you, because I tried sometimes and it's like they don't really know about this issue on wrapping HTML and React 3 Fiber stuff together with this HTML from dry. It's like they don't know that this thing exists, okay? Only if you tell the ChatGPT that, oh, look, blah, 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 but so it's not helpful in this specific cases. And we forgot about our problem, but you see that we have another error. Cannot set properties of undefined width, but we don't have that error anymore. Let's go back to our code. Here in the app component, just drag this drawing canvas outside of canvas. Okay, this is now complaining simply because we need the parent element. So JS expressions must have one parent element. Just add an empty tag. Okay, you see we have canvas separated and drawing canvas separated. And that error should not be there anymore. Let's check. I said should not be there, or I am a liar. No, it's not there, but we just need to expand this canvas to make it full size. Okay, you see we can draw. We can draw only here because, as I understand, the canvas is here. Yeah, let's fix the styles and anything that might cause this. I have 2 emails, by the way. PayPal and Upwork. Okay, not now. I think that black screen there was the 3D model, actually. I mean the painting brush. But we need to fix the scale, or maybe, yeah, I think it's either that black thing. Let's check it again. I think it's the 3D brush. And when we don't have lights in the scene, we cannot see the objects. The material of the 3D object will be black because it needs some light to make it visible. Okay? So the only material in Three.js that do not need the light to be visible is the basic one, the mesh basic material. But usually these materials are the mesh standard materials. Okay, so we need lights, that's it. Let's add lights, let's fix the scale, and let's make the canvas full size, since I see that I can draw only here. So let's fix these small details, which are not really problems. Okay, so I fixed this position and rotation and scale of the painting brush. So now it looks okay. Take a look. We can see now the painting brush. We cannot move it because we don't have the logic yet to sync the mouse movement with the painting brush model. Okay, that is what we are going to do now. So we want to sync this 3D painting brush model with a mouse movement. We move the mouse, we also move the model. And then we can draw with this model, okay? So I want to draw with the tip of this painting brush by moving the mouse, and when we drag the mouse and click, we can draw the line. Okay, let's do that. The first thing that we should do is in the drawing canvas component, we should take this state variable is drawing, and let's move it to our main component, app component, because we want to pass down this value, this state variable, okay? And in React, we cannot do it like from the child to the parent, but React has this unidirectional data flow, so from parent to child. We also have state management, but we don't care about state management now, like for example Redux, etc. So grab that state variable from the drawing canvas component and move it here. Additionally, we should also take this canvas ref and move it in the app component. Now we will get an error because this canvas ref is undefined now. We don't have any canvas ref passing it here, but we will pass this as props, okay? So we will accept a prop canvas ref, and so we can use it from the parent app component to this drawing canvas component, which is a child of it. Okay, you can see drawing canvas is a child of this app component. But since we want to use it also in SketchUp, so we want to use this state variable, for example, in SketchUp, in drawing canvas, also, you know, SketchUp has this painting brush inside. So since we want to use it in two childs, we move it here in the main parent. We move it here to the parent, which is up. And from up, we can pass it down to drawing canvas and to SketchUp. And then from SketchUp, pass it to painting brush. Okay? It's easy. Might look confusing, but it's easy. So first of all, we have an error because we don't have the use state. So import use state. When you have it like this, you just like delete a character, write it again, and it will be suggested from VS Code. Okay. The same thing here. Suggested from React. So we imported this use ref and use state from React. Now, as I said, we should pass down as props to drawing canvas and also to SketchUp. But before passing down these props, this drawing and canvas ref, I want to create another state variable. This state variable is about the mouse position, since we want this new state variable is for the mouse position, since we want to keep track of the mouse position, because we want to sync this mouse position with the position of our 3D painting brush model, okay? So we want the variable to keep track of the mouse position. And let's create that variable. So mouse position. Actually, this will not be an empty string because the mouse position will have inside, will keep track of the position of X and the position of Y. So these two coordinates, okay? So it will be an object, and inside these key value pairs, X will be 0 and Y will be also 0. Now that we have this new state variable, let's pass them down to these components. So first to drawing canvas. Is drawing equal is drawing. We also need set is drawing because we will set that in the drawing canvas component. So also pass that. Okay, let's pass the mouse position. And finally, let's pass canvas ref. Okay, now before passing these variables to SketchUp component, let's finish first with this component, drawing canvas. So before passing them also to the SketchUp component, let's finish first with this component, drawing canvas, since we just have a few lines of code. Okay, so here in the drawing canvas component, create an object inside because it will handle all these props, and that is an object. And let's pass first is drawing, then set is drawing, then mouse position. It was set mouse position. Yes, actually, okay, mouse position, yes. And then canvas ref. No, actually, I made a mistake. No, I don't need this mouse position. I just need the setter because I want to just simply set the mouse position here in these two functions, start drawing and draw. Okay, so I need the setter. Back here, I will pass this set mouse position. And also here, change it, set mouse position. Okay. So let's scroll to these functions, start drawing and draw. Here, we will add simply a single line of code. We will call this setter. Set mouse position. Inside, we will set X to the offset X and Y to the offset y. The same thing in the draw component. So the same thing. What we did here, when the user starts drawing in this function, start drawing, so this function, it means that the user started drawing. So when the user starts drawing or continues drawing, which is this other function, draw, it means that the user continues drawing. So in these cases, we update the mouse position state variable using this set mouse position. So we update the state variable that we created in our app component by passing this object with the current x and y coordinates of the mouse cursor. Okay? So we pass this object, which are the current x and y coordinates of the mouse cursor, obtained from this offset x and offset y. Okay? So obtained from this, from the native event. By updating this state variable, mouse position, we can access the current mouse position in the SketchUp and the painting brush components that we will do it now, okay? Which will be used to position the 3D brush model based on the mouse position. So we move the mouse, also the brush model will move, and that's it. This is the idea. Now let's also pass these variables from the app component to SketchUp and then from SketchUp to the painting brush. Okay, let's do the same thing. So is drawing, set is drawing, and in this case the mouse position, not the setter. And in the end, the canvas reference. Okay, so now that we passed these props, let's accept them here in the SketchUp. So create an object here. We accept these props. So they were is drawing. Okay, let's just copy paste. First is drawing. Then set is drawing. Then mouse position. And here I already know canvas ref. Okay, canvas ref. So now that we accept these props that we get here, that we are passing from the app component here, you know, the game of props, the props drilling. So we pass these variables here, and we get it here as arguments. Then we want to pass it to the painting brush, and the same thing, to pass it to the painting brush. Let's pass it like this. So is drawing, set is drawing, canvas ref. Again, let's accept these arguments here inside the painting brush. We already have these props here. We can use them like props dot is drawing, props dot set is drawing, props dot, but we don't know in this way what are the props that we are passing. So we don't know. So it's more readable to pass it here. And let's not use props, but use directly the variable. Okay, so you have two ways to use props that is drawing, props that mouse position, or pass them directly here. In this case, 3 dots here to get all the other props. This is the spread operator in JavaScript. So we get all the other props, but I pass also this is okay. I will do it just with copy pasting, so I don't make any typo. Okay, we have the props. Now let's add this logic to make it possible so that when we move the mouse, we also move the 3D model of the brush. Okay, here we will do some math. Here we will do some math, but don't be afraid. We will not build a rocket, but we will try some simple stuff. So let's try it. The first thing I need is a use frame, and let's import a use frame. It is imported from React, so here. Oh no, sorry, use frame is from React 3 Fiber. My mistake. I always forget. So import use frame from React 3 Fiber. It's not part of the React library. And here, let's make some space for readability. Let's create this use frame. This use frame is like similar like use effect, the syntax. So the syntax is use frame, parenthesis, then inside an arrow function. So arrow function is like the anonymous function is parenthesis, like this. So we have this use frame. Here we will add the code. The first thing, as we did before, we need a reference to this 3D model. Okay, so we need a reference to attach it to this group. So we know that we can handle and manipulate that 3D model. Okay, so let's create a reference. Call it brush ref equal simply use ref parenthesis to call it. Okay, it is not imported. Yes, it's imported. Cannot be called inside a callback. React hooks must be called blah 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 blah. Of course, we should not create it inside the use frame. I will explain in a bit what is the use of use frame in React Fiber. So outside of this, okay, now that we have this reference, let's add it also to the group. So here, ref, add this brush ref. So now we attached this reference and we can reference this group, which is our 3D model of the brush. Let's create a variable for this brush, okay? Because we have the reference, but let's create a variable for this brush. And we always use that current, remember, that we used before. For that, const brush equal to this reference brush ref dot current. Oh, sorry. Now we have a variable for the brush. And here we can check. We can add an if statement. So if this brush exists, if we have a brush, if it's not null, so if it's true, if brush, so if true, it's not an error, it's just because we have an empty block, but we will add the logic now. So the logic is if this reference exists, so if the model is loaded, we proceed with the positioning logic. And in this case, we will extract the x and the y coordinates. And in this case, we extract the x and the y coordinates from the mouse position prop that we get, remember, and convert them into normalized device coordinates, which in short is NDC, normalized device coordinates. We will use a 3-vector2 for this. Please don't get confused. NDC, normalized device coordinates, is a coordinate system where the range of values is between -1 and 1 for both x and y axis. So let's code. Enough talking. So the x position will be const x pos equal to this mouse position that we get as a prop, remember, that you already know, and you guessed it, position dot x. Sorry, not position, it's just dot x, because this is already the position, okay? So if we console log it, this is already the x position. If you go back here and check, this is the x position because we passed that offset x, okay? So mouse position dot x. The same thing, y position dot y. Then create a new variable for the mouse, and as I said, we will create an instance of the class vector2 from 3, okay? You already know vector2 and vector3, I suppose. So here below, const mouse equal to new. When you create an instance from a class from Three.js, you add this new keyword, so new instance of that class. You know, the object-oriented programming language, etc. No, I'm not going to bore you to death with object-oriented programming, but simply have the idea, we create a new thing, a new stuff. Okay, so new instance of that. New 3 dot vector2. But this vector2 is uppercase or lowercase. I really don't remember. It's not suggested because we don't have this 3. Okay, sorry. Just leave it lowercase. Let's import this 3 first. And to import Three.js, which is the Three.js library, we need this vector2. Just import it like this. Import star S3 uppercase is just a standard rule from 3. Okay, and here you can use this 3 object. You see, may not exist. Uppercase, yes, it's uppercase. Okay. Okay, it's uppercase. Or To make it better for the bundle size, you can just grab this vector2, not the whole object of 3. Uh, to do that, you can just get this vector2. For example, here, import vector2 from 3, etc., etc. Okay, but we don't care at this moment. We are just building our project. Later, you can optimize it, like just get the classes that you are using. Don't import the whole 3 object, because the whole 3 object is very big. Okay, the same thing that you do with Bootstrap. Okay, if you used Bootstrap, and I suppose if you are here, you play it with code. So in Bootstrap, when you get, like, you don't get everything, you don't import all the Bootstrap library, but you get those elements that you need. Okay, elements or whatever they are, doesn't matter. The classes or how you call it. I completely forgot Bootstrap. I don't use it since ages. I don't know why. I used other libraries, but whatever. You don't import all the Bootstrap. Okay, so you just import the things that you are using inside. In this case, I want to use only the vector2 class, maybe also the vector3, so I don't import the whole library. Okay, so we created a new instance of this vector2 inside here. Let's write some confusing code, okay? Because we are doing math here. It's not just an easy peasy application. What you thought? I'm joking. It's just easy stuff. So open parentheses. In math, you open parentheses to do some calculations inside, to divide multiplications and additions, etc. So open parentheses, and here x position. So the variable x pos dividing window dot inner width times 2 minus 1. Okay, what is this weird line of code? But let me finish it and then we can explain. The same thing, but here y, and instead of minus, plus. Okay. So what we did here, we create a new 3.vector2 object called mouse. A vector2 is a two-dimensional vector that represents a point or a direction into the space. In this case, we use it to store the normalized mouse coordinates. We calculate the normalized mouse coordinates by dividing x position by the window width, which we get with window.innerWidth. It's nothing else than the window width. And we calculate the normalized mouse coordinate for the y by doing the same thing, like y position by the window's height. And this gives us a value between 0 and 1. Okay? However, in WebGL, which is the technology behind Three.js, the coordinate system ranges from -1 to 1 for both x and y axis. So we multiply the normalized values by 2, okay, and subtract 1 from this x coordinate and multiply it by -2 and add 1 to the y coordinate. This maps the mouse coordinates to the WebGL coordinate system. Okay? I hope it's not confusing. If it is, please replay this part, go back and replay, but I will repeat it again, and I hope it sticks or it makes it easier to understand. So we calculate the normalized mouse coordinates by dividing x position by the window's width and y position by the window's height, which we are doing here, the first part here. Okay? And as I said, this will give us values between 0 and 1. But in WebGL, because Three.js uses WebGL. WebGL is the technology behind Three.js. Okay, Three.js is a library. So in WebGL, the coordinate system ranges from -1 to 1, not from 0 to 1. Okay, for both x and the y-axis. That's why we multiply the normalized values by 2, subtracting 1 for the x coordinate, and multiply by 2 and adding 1 to the y coordinate. This will map the mouse coordinates to the WebGL coordinate system. Okay? I hope I explained this for you. You can think of this normalization process as shrinking the screen to a smaller range. For example, -1 to 1. So that's easier to work in the 3D space, okay? So think of it like shrinking the scene. So just think of this normalization as we shrink the screen of our computer. So we shrink it to a value of -1 to 1. So it's easier for us, okay? Now let's add a variable for the vector, which will be a vector3. So here, don't make a mistake inside the vector2 parentheses. So behind that, we are okay, we are inside. So create a new variable. So const vector. And again, we create a new instance from the class vector 3 in this case, not vector 2, and always from the 3 main object. Okay. And again, you can also import only the vector 3, not the whole library. So the keyword new to create new stuff, we access the 3 main object, and then we get the class vector 3, open the parentheses, and here inside we pass the mouse X and the mouse Y. Mouse is this variable here that we just created. Mouse X, mouse Y, 0.5. So what we did here this time, we created a new vector 3 object called vector. We named it like this, a simple name. This vector 3 is similar to the vector 2, but it represents a point or a direction in a 3D space in this case, not a 2D space. Because we mentioned before that the vector 2 represents a point or a direction in 2D space. In this case, a vector 3 represents a point or a direction in a 3D space. Okay? Then we set the x and y components of the vector to the normalized mouse coordinates. This is the normalized mouse coordinates that we just talked about a minute before, which are stored in this mouse variable, okay, which is an object. And then we set the z component to 0.5. This is the z component, okay? So for x and y, we set to the normalized mouse coordinates, which are stored in this mouse object. And then we add 0.5 for the z component of the vector. Okay? This z component here, the third value that we pass, determines how far the brush is from the camera. Okay, is the z axis. So how far is from the camera. By setting it to 0.5, we position the brush slightly in front of the camera because, you know, we have the camera. The camera are our eyes. And if we both have camera and this Z component to 0, which is the default value, the origin, everything that is put in the scene has 0, 0, 0 coordinates, okay, which is the origin. So if both of them are 0, we cannot see anything, okay? It's like having something really near our eyes, okay? So we slightly put it in front of the camera. This is the idea. Now here, let's add a short code vector dot on project, and here we pass the camera. And what's this camera? We don't have the camera here. You see, it is complaining camera is not defined. We don't have the camera. So let's import that. And usually in React 3 Fiber, we import the camera using the hook from React 3 Fiber, use 3. Use 3 is like using the 3 library from Three.js. It's a hook that manages in a simple way. For example, in this case, we want the camera. So const camera equal use 3. We imported it from React 3 fiber, you see here, up at the top. You see it here at the top, use 3. But not like this, we don't pass camera here. What we do with this hook, use 3, the same thing that we did with the use GLTF hook. Remember with the use GLTF hook? We destructure the camera here from this use 3. Okay, this is how we get it. Now camera is defined. And what we did here, we use this onProject method, which is a method of the vector, to convert from screen coordinates to world coordinates. Okay, the onProject method takes the camera as an argument and uses its projection matrix to transform the vector from 2D screen to 3 world space. Okay, now what we did here, we used this onProject method, which is the method of this vector, to convert it from screen coordinates to world coordinates. The onProject method takes the camera as an argument and uses its projection matrix, it's called projection matrix, to transform the vector from 2D screen to 3D world space. Okay, again, to transform the vector from 2D screen space to 3D world space. You can think of this step as taking a flat image, for example, the screen, and projecting it onto a 3D world, like shining a light through a transparency onto a 3D object. So taking this flat image and projecting it into a 3D world. Okay, so the next step would be we will create a new variable again, and let's call it direction, or short dir, const dir. And equal use this vector dot sub open parenthesis, and let's pass inside as a parameter camera dot position. And we normalize this with the method normalize. And the method has parentheses. To explain, here we calculate the direction from the camera to the mouse position in the 3D space. We do this by subtracting the camera's position from the vector using the sub method. Okay, so we subtract the camera's position from the vector using this method, sub. This gives us a new vector that points from the camera to the mouse position. Okay, we then normalize the resulting vector using this method, normalize. Normalization means adjusting the vector's length to 1 while preserving its direction, like taking a stretched rubber band and releasing it back to its original size without changing its orientation. Next, let's create a new variable for the distance in this case. Const distance equal, it will be equal to the camera Z position. And here add a minus. Which will divide the direction Z. So divide dir.z. To explain this part, we calculate here the distance from the camera to the mouse position along the z-axis. So we do this by dividing the negative of the camera's z position. You see, I added this minus here. So we divide the negative of the camera's z position by the z component of the normalized direction vector, which is this one that we created before. See, this is the normalized direction vector. Okay? Again, I will repeat this part. We calculated the distance from the camera to the mouse position along the z-axis. And we did this by dividing the negative of the camera's z position by the z component of this normalized direction vector. So dir.z. This calculation is based on the formula here, okay, which uses the properties of similar triangles to determine the distance. Let's continue. I know you are hating this part, I know. But bear with me, not for too long, because we are finishing here. Now let's create a variable for the mouse position, which is the actual position of the painting brush in 3D space. Finally. So create a variable. Let's call it mouse position, mouse pos for short. Here, let's write the code first, because this is a bit this needs a bit of explanation. So let's write the code and I will explain what it is. So camera dot position, clone it, dot clone, and then use the method add, then use this direction variable, so dir. We access this multiply scalar that we pass the distance. Okay. We are getting there, guys. Please bear with me. To explain this part, here we calculate the actual position of this painting brush in the 3D space. We start by cloning using this method here, clone, you see. By cloning the camera's position to create a new vector with the same values, because we clone it to create a new vector with those same values. So we start with this. We clone the camera's position first. Okay? We then use this add method to add the product of the normalized direction vector. This one, remember, is the normalized direction vector. Then we calculate the distance to the cloned camera's position using this add method. And by using this multiply scalar, we multiply the direction vector by the distance. We multiply the direction vector by the distance, resulting in a new vector that represents the offset from the camera to the mouse position. Okay? Maybe I should repeat this part. Here we calculate the position, the actual position of the painting brush, the 3D model in the 3D space. So we start by cloning this camera's position. We use this clone method. Okay, to create a new vector with those same values. Then we add the product of the normalized direction vector here with this add method, and the calculated distance to the cloned camera position. And this multiply scalar is used to multiply the direction vector by the distance, resulting in this new vector, which will represent the offset from the camera to the mouse position. And this resulting mouse position here, variable vector, represents the 3D position where this painting brush should be placed in the scene. Okay, you get it? This will represent the 3D position where this painting brush will be placed in our scene. So let's add the last part. So here the last part, brush dot position dot copy, using this method copy, and here we pass the mouse position. It's not mouse position, it's no, mouse position is the original prop. Here, this variable here, mouse pass. Sorry. So here we set the position of this painting brush, which is the 3D model, to the calculated mouse pass vector, this vector here, using this method copy. This will move the brush to the desired position in the 3D space, synchronizing the movement with the mouse cursor. This is all what we wanted, right? So synchronizing the mouse cursor with the 3D model brush. And there you have it. Maybe it's a detailed explanation, I don't know. Maybe I didn't explain it as I should, but I hope you get it. Or if you don't get it, please bear with me. Play it again, trying to go line by line. The best thing that you can do, read documentation about these methods. Try to understand the vectors, the vector 2 and the vector 3. They have the same meaning in all the 3D systems, but you can read the Three.js documentation or any other article that explains the vectors. Okay. I don't remember if I explained the use frame hook. So why we chose this hook, use frame, why not use effect? I don't remember, but I will explain it again if I did. If not, I should. So in React 3 Fiber, this use frame hook allow us to execute code on every frame of the 3D scene. Okay, this is the idea. The use frame hook is to execute the code inside on each frame. This is on a 3D scene, because on a 3D scene, you know, you render things on each frame. You can think of it as a way to continuously update and animate objects in the 3D world. Okay? When you animate things, you want to update it on each frame. This is, those flipbook where each page represents a frame and you can draw or modify the content on each page to create an animation. The flipbooks. That's it. This is the function of the use frame. Okay, now let's test in the browser if it works, if all this work is done correctly. I hope so. Okay, it's not working. Okay. I feel a bit ashamed now after explaining all that stuff, and now it's not working. And of course, it's my fault. I did something wrong. Now, who can find this bug now? So, to investigate here, oh, I see it. Now go and find that error. We don't have any errors. That's the problem. If we had an error, it would be easier. So we get the camera from use 3, it's okay. We get this reference, it's okay. We use the use frame. We create this brush and get the reference. Brush current, it's okay. If brush is true, X position, mouse position X from the prop, it's correct. Y, it's correct. We create the mouse and assign it to this vector 2. X position divide the width. We multiply by 2 and subtract 1. It looks correct. Yes, add 1 looks correct. Vector, new vector. Why? Oh, eh. Yeah. I mentioned before that this is the negative value of this y. This is the negative. Yeah, I think this is the problem. Let's try. Okay, yeah, I see I can move. Finally. That is the problem. We have a problem with the rotation. We have the problem with the rotation, but we can fix that. And also the mouse is far away from this model. So we have two issues. Fix the rotation and this. You see, the cursor is far away from this. The cursor should be at the tip of the pencil. We should fix that. Now let's fix these two problems. Okay. So the mouse position was far away from the 3D model. Okay, another stupid error here. You see, it's window.innerWidth, inner.winnerWidth. It should be inner height here. Okay. Let's check. Okay, now the mouse and the 3D model, they are synced together. Even though the mouse cursor, it's not at the tip, but it's at the middle. And this is a problem that we should fix. I know how to fix it. We will fix it later. But let's change this rotation and position of the model. So the x is math.pi, which is, as we saw the brush horizontally, which means it is 180 degrees. So maybe make it 90. So divide it by 2. This will be the y is okay, 0. And for the z, math.py divided by 2. Let's check now. Okay, now it works. Perfect. Okay, the mouse follows the 3D model. The rotation looks perfect. When we move it, it also makes this inclination. It's perfect, I think, when we move it up. Okay. Yes. This is exactly what I wanted. So the only problem now is to change this origin of the cursor, not at the center of the model, but at the tip, because naturally you will draw with a tip, not from the center. Okay. And this is a problem that ChatGPT cannot help you. I wrote a post about this on my LinkedIn profile. I also posted on YouTube, but it didn't get any attention. So this is the problem that you cannot solve with ChatGPT or Gemini or whatever, because it is very specific. It's very easy to solve, but it just requires some knowledge and experience with the 3D models. I tried, I just out of curiosity, I also gave hints to ChatGPT, like, look, you can solve it like this. I mentioned the pivot or pivot, I don't know how do you say that, the origin of the cursor, but no, ChatGPT couldn't solve this problem. We will fix it together with Blender. We need Blender for this, and we will change the origin and put this cursor of the mouse at the tip of the model. Okay, let's do that. Okay, so let's open Blender. If you don't have Blender, download it. It's free, it's open source. Then when you open it, here, File, Import GLTF 2.0, click it and import the file where you have it. Okay, I have already imported it. So at this point, press A to select this model. Then after selecting the model, press Tab to go into edit mode. Or here you can see object mode, click it and edit mode. Now press Shift and select multiple vertices here at the tip of this model. So let's choose okay. Now press Shift plus S and pick cursor to selected. Now go back to object mode, then click object here at the menu bar, then set origin, and then origin to 3D cursor. Now, as you can see, you have this origin here at the tip. Simply export this model and you are good to go. So File, Export, GLTF 2.0. Choose the folder and you are ready to use it. Okay, so in this final part, we are going to add a very special touch to our web application, a 3D scene based on one of the most famous paintings in the world, Vincent van Gogh's bedroom in Arles, as you can see here. I'm sure that you already know this painting, but did you know that Van Gogh actually painted three versions of this room? He was so fascinated by the simplicity and tranquility of his bedroom that he decided to capture it multiple times. This painting depicts Van Gogh's bedroom in the Yellow House. It's incredible to think that this iconic piece of art captures a real, intimate space where the artist lived and worked. Sadly, the Yellow House was destroyed during an Allied bombing in 1944. But through this painting, a part of it lives. One of the things that I like about Van Gogh's work is his use of color as a means of expressing emotion. In this bedroom in Arles, for example, the bold, vibrant colors create a sense of warmth, of comfort, inviting us into the artist's private world. It's a reminder that even the simplest, most everyday spaces can be filled with this beauty and meaning. Interestingly, Van Gogh was inspired after being bedridden for several days. He described it as simply his bedroom, but I think it represents so much more. Maybe it's a reflection of his state of mind, his longing for peace and stability in this turbulent life. But let's continue with our web application. So to be able to use this scene, you can find the link in the description or in the GitHub repository. Download it, the file. Then again, go to this website, upload the GLB file, and you will get this beautiful model. Copy the file or make some adjustment here. For example, I don't know, but copy this file and go and create a new component. Okay, so I already pasted here. I have this new component for the Van Gogh room, and it's the same thing. The things that you already learned. So we created this JSX component from the GLB file. We create this variable model path, pass it here. It's the same thing with the structure nodes and materials with this use GLTF. We pass the props here. This is the group of meshes, which are different parts of the scene. It doesn't matter, it's the same logic. In the end, we preload it normally, pass it this model path. So this component sets up the 3D scene on Van Gogh's bedroom, complete with various meshes and materials that make up the room. Let's take a look in the browser how it looks. You see, it's very beautiful. We have these two options, start drawing or explore the room. And I really like this 3D scene. I don't know you, but I love it. And maybe later we can contribute to this project by, I don't know, making a mini game inside this room, like finding objects or clicking at these artworks here and show information. We can add animations to this room and other features that I will think about. Okay, so maybe we can contribute, me or someone else, if you prefer. Until now, I had nobody contributing to my projects, but you are welcome, you know. Okay, so this is the new scene. We can start drawing. we have also this Van Gogh avatar, and it's the same logic to import 3D models. If you want to know more about how to create 3D avatars, how to add custom animations to it, how to play these animations based on interactivity of the user, please check out my other tutorials. For example, in my latest one, the 3D classroom, I create 3D avatars based on your image, but you can find another one, like for example, Van Gogh. And we add animations from Mixamo. Mixamo is a platform online that provides you with custom animations. Okay, so please go check that video and you can add your own models with your own animations. Make it cooler than it is. Okay. So what we did, we converted this GLB model into this JSX declarative component. Then we import it in our app component. Okay, we import it here, and here I made some changes. I made some changes here to conditionally render the Van Gogh room scene or the drawing canvas. Okay, as you can see, this is a simple logic. So I thought there was no need to go line by line here and explain everything. But I also created a new component for the menu, which is this one, info overlay. This component displays a welcome message and conditionally renders the buttons based on the set drawing canvas and set explore room that we receive as props from the app component. So when clicked, these buttons will update the app's state to show either the drawing canvas or the Van Gogh room. So in this updated app component, we use conditional rendering to display either Van Gogh room or the SketchUp component based on the show drawing canvas, this new state variable. Okay, so based on this state variable, we display conditionally the Van Gogh room or the SketchUp component. As you can see, if it's not show drawing canvas, display this Van Gogh room. So if it's false, display this one. Okay, or if show drawing canvas is true, show this component SketchUp, which contains also the Van Gogh avatar and the brush model. And we also render the info overlay component when neither the drawing canvas nor the explore room is active. Okay, so it will be the menu. Last thing, I've also added this camera manager component that has this code inside. You can copy and paste it. You can find it in the repository. But basically here, this camera controls component from React 3 Dry. So we import this camera controls from React 3 Dry. It provides a convenient way to control the camera's behavior. For example, we set some constraints such as the minimum and the maximum zoom levels, the allowed angles for polar and the azimuth movements, which is up and down and etc. And we disable the panning. These settings will give the user a nice controlled experience while we explore the room. Okay, and that's it. Maybe here in the painting brush component. I think we are not using this is drawing, neither this set is drawing, so we can delete these props. I think neither the canvas component. I thought we might need it, but we don't need it. Okay. So we only use this mouse position. If you can see this in the SketchUp component, we are passing only the mouse position. Okay. And that's it. This is everything. If you think you can add other cool features, I don't know, like interactive elements or simple beautiful styles or beautiful animations, or you can improve the 2D UI or the UX, please welcome. Go ahead and open a pull request and contribute to the project. Thank you so much for joining me on this tutorial on creating a 3D drawing app inspired by Van Gogh's bedroom in Arles. I hope you enjoyed it, and if you find this tutorial helpful or interesting, consider subscribing to my channel for more content like this. I'm always working on new projects and ideas, and I would love to have you along for the ride. Feel free to leave a comment with your thoughts, questions, or suggestions. I'm always happy to hear from you and help you however I can. Until next time, keep creating and exploring the exciting world of web development and 3D graphics. See you in the next tutorial. Bye.